Now, let's do partial y star, partial t. That's a new one. Let's get this one. Oh, I shouldn't have erased that y star, should I? Let's put it back up here quickly. Y star is this. Okay. So who wants to do this partial differentiation? Esteban, I haven't called on you in a while. What is this partial derivative? Partial y star, partial t. And what rule of differentiation are you going to use to get it? Right, right. So get us started. Right, okay, the derivative of the numerator with respect to t is what? 0, right. Okay, so we have a 0 times the denominator minus 1 times okay.
Oh, sorry, now we're doing it
with t, exactly. It's just b. The coefficient on t, make sure I write the right thing this time. The derivative of that denominator with respect to t is just b. Okay, so it's minus b times, yeah. Exactly. Over the denominator squared. And if we take into account that this is just 0, it becomes equal to minus b times and suppose we wanted to write this in terms of y star, what would it be? Yes, it's just minus b times y star over 1 minus b plus bt. Okay. And you can see this is quite large. Quite large, but what's its sign? And this time it's going to be negative because of this negative sign here. So this is going to be negative. This, if you forget about the negative sign, this is positive, but you got that negative sign, which makes it negative. So in words, what does this mean? In words? Ryan, what does this mean in words?
Taxes maybe in the opposite direction. The taxes increase output.
Okay, now let's be careful of our words. There's a big T for taxes, tax revenue. Little t is tax rate. So, okay, go ahead.
The tax rate increases, output decreases.
Okay, the equilibrium value of national income, or output, if you like, goes down. Yeah, they move in the opposite direction. Right. The tax rate and y star move in the opposite direction. The higher the tax rate, the lower the equilibrium value of national income. So if we wanted to raise national income, what would be one way of trying to raise national income? Lower the tax rate. Lower the tax rate. And that's just something that we did a couple of years ago, lowered the tax rate to try to stimulate consumption and national income. Okay, all right. Now, you could do this same analysis. Suppose you work for the Treasury. If you are working for the Treasury, you might be concerned about the equilibrium value of tax revenue, and also maybe the size of the deficit. So then you would be interested in looking at T star and how a change in one of the parameters or exogenous variables affects T star. So how would you begin to do that? I'm not going to work all the way through it, but how would you, if I ask, do a comparative static analysis on tax revenue? How would you go about doing that? See, ultimately, our goal is to get an expression for T star expressed in terms of parameters and exogenous variables. Okay, that would be the first step. Now, a quick way of doing that, since we know what Y star is, what is T star going to be? What's the expression for T star going to be? I'm just trying to save us a few steps. Yeah, because we have T is equal to Ty. So that also means the equilibrium value of taxes is going to be T times Y star. We've already got an expression for Y star. So all you have to do to get T star is just to plug into this formula for Y star. And you recall our expression for Y star was this expression within brackets. Okay. So you've got your expression for T star, and I'll leave it to you to find these derivatives. Find these partial derivatives. Find those signs of those derivatives, and then interpret the meaning of those in words. Okay, that might make a good test question for the next exam. Okay. All right. Okay, any questions over this? It's pretty straightforward, comparative static analysis. You just need to first solve for the equilibrium values of the endogenous variables, and then just differentiate. Just use partial differentiation. And then see if you can sign the partial derivatives. So far, in every example we've looked at, you can always sign the partial derivatives. Now, in a more complicated model, that wouldn't necessarily be the case. So if the sign of the partial derivative could be either positive or negative, then that means you can't unambiguously say what the effect of this parameter is on the equilibrium value. Could be positive or could be negative, depending on the sign of the partial derivative. But so far, all these partial derivatives we've been able to sign. So you can tell unambiguously what the effect, what the qualitative effect of that parameter on equilibrium income or whatever is.